Dear fellow researchers and friends, my name is Joseph George. Today, I would like to discuss the drawbacks of the theory of relativity. Einstein developed the theories of relativity, which are fundamentally based on two concepts. First, the speed of light is a universal constant. Second, no space-filling ether exists. Relativity is regarded today as one of the greatest achievements in our understanding of the universe. Since it is founded on the aforementioned concepts, any inconsistency with either of them would negatively impact relativity, and consequently, necessitate a rewriting of our current understanding of the universe. Intriguingly, if space-filling matter exists, it would be attracted by gravity, and every massive body would have a denser envelope surrounding it. The speed of light would be influenced by these regions. If this is the case, let's imagine a galaxy, such as our own, for example. Current estimates suggest that the Milky Way galaxy comprises more than 100 billion stars. We know that the Milky Way resembles a giant disk with a bulge in the middle. It is a spiral galaxy with stars arranged in such a way that the central region exhibits a higher concentration of stars, forming a bulge. As the distance from the center increases, the star population diminishes. Now, let's imagine a beam of light traveling from one edge of the Milky Way to the opposite edge. Since each body has a dense envelope, as light travels closer to a large body, the dense region will affect the light's speed. As a result, this could lead us to believe that light does not have a constant speed across a galaxy. The same principle applies if light travels through a galaxy cluster. In essence, if it is proven that space-filling matter exists, then the idea of the constancy of the speed of light would become questionable. The fact that variations in the speed of light cause refraction provides an alternative explanation to Einstein's famous concept of gravitational curvature of space-time. It has already been proven that a massive object can bend light, and according to general relativity, this phenomenon is an effect of a body's gravity on surrounding space-time. Therefore, it is crucial to verify whether or not space is filled with matter. It is relevant to mention the results of the Michelson-Morley experiment in this context. However, it may also be possible that alternative methods exist to test the concept of space-filling matter. Now, let's think about one of the most interesting and intriguing phenomena in nature, the mass defect. The mass defect was discovered by British physicist Francis William Aston in the early 20th century. Aston's work on mass spectrometry led him to observe that the total mass of a nucleus was slightly less than the sum of the masses of its constituent protons and neutrons. In the special theory of relativity, Einstein proposed the idea that matter and energy are different manifestations of the same thing and one can be converted into the other. Einstein's ideas gained widespread acceptance following his explanation of the precession of the perihelion of Mercury. This in fact led to widespread acknowledgement of his other concepts too, such as the mass-energy equivalence principle, among others. Since I was young, I was very much fascinated by the unmatched amount of energy released by nuclear reactions compared to chemical reactions. I was very keen on knowing the actual mechanism behind how a nuclear reaction releases energy and how the release of chemical and nuclear energies are different. I knew that chemical explosions are the result of a change in the state of matter. More specifically, I understood that the sudden increase in volume results in chemical explosions. However, I learned from the special theory that nuclear energy is different, suggesting that nuclear energy is the result of the conversion of matter into energy. I investigated this idea and examined how the products in a nuclear reaction behave, such as product nuclei, alpha particles, beta particles, neutrons, neutrinos, etc. I also examined their speeds. When a nuclear reaction occurs, for example, nuclear decay, fission reactions, or fusion reactions, the released particles move at very high speeds. I realized that a mass defect imparts a large amount of kinetic energy to the products. In fact, heat energy is produced when these particles collide with surrounding matter. This led me to conclude that a mass defect does not directly produce heat or light, rather, heat and light are produced when the product particles hit the surrounding matter. This kinetic energy of the particles is analogous to the kinetic energy of a bullet, which is propelled by the explosion inside the shell. This led me to think that perhaps the mass defect is exploded violently and propels the products in different directions. If this is the case, then nuclear energy ultimately results from a change in the state of matter. In other words, the mass defect in a reaction is converted into an extremely fine form of matter, and the released energy with a mass defect is due to this conversion. Mass defect is a common occurrence in the universe. Every active star, supernova explosion, neutron star collision, black hole merger, etc., creates mass defect on a large scale. This leads us to conclude that space is filled with this form of matter. This can provide new insights into many important phenomena in the universe, which are explained and predicted by the theory of relativity. In the upcoming videos, we will discuss each one in detail. My book is now available for purchase. Please visit www.amazon.com/author/Adam.